Alrighty, so for problem number 21, let me read it to you guys. It says, for the circuit shown in figure 1810, we're asked to transverse loop 3 opposite to the direction shown and demonstrate that the resulting equation is the same as that obtained if you followed the direction of the arrows. And then part B, we're supposed to repeat that procedure by traveling loops 1 and 2 in the direction opposite that had been taken in the text and demonstrate that the equations are equivalent to those in 18.5. And so for part A, let's start with that. For part A, what we're going to do is we're going to travel the loop in the opposite direction. So we're going to go around loop 3. Alrighty. Okay. And we're gonna calculate the voltages. And so if we go in the opposite direction, then our voltage should be negative V sub 1 plus the voltage of the resistor. And let me preface this by saying that voltage is always equal to I times R. And so I'm starting here, and then I've got to find the voltage across here, which is equal to I times R. So I1, the next voltage, is going to be IR, or I sub 1, R sub 1. And then the next voltage would be right here, which would be like right here, which would be plus I sub 2, R sub 2. And then the next voltage would be actually, let me think. I think that's everything. And so then the sum total of that should be equal to 0, right? Because of Kirchhoff's rule. And so I think we're done. Let me think this through here. Another way we could write it is if we were to go in the opposite direction, we would just reverse the sign. So that will be a positive V1, V sub 1, minus IR, I1, R1, minus I2, R2, which is equal to 0. And so to prove that that basically what we're saying is that this is the result of the equation for loop 1 plus equation for loop 2. Okay? Now for part B, we're going to go around loop 1 . You might be thinking, well, how do you get that? Well, part B kind of shows part A. I don't know why in this textbook. Sometimes the answer for part A, it's like they ask you to do something, and then part B is like how you got the answer. So now we're going to do this in reverse. So very similarly, for part A, for part B, we're going to start here. All right, so I get negative V1 plus, and I gotta let me slide back up here. So we're going to go backwards. So the next thing we would do is address this thing right here, which is going to be I3 R3. So we say I sub 3 R sub 3, which is really this thing here. Okay, now let me erase that. It's getting a little messy. And then lastly, that will be plus V2, all right, which is this right here. And then the last resistor, which will be I1 R1. Okay, and then all that stuff would equal 0. And then if we multiply both sides by -1, in other words, if I take this whole thing and multiply it by a -1, then my second, this will be like forward, like we're reversing it, I would end up with 0 is equal to +1 plus I3 R3 plus V2 plus I1 R1. And so this is like going forward. Okay. So this is just loop 1. So now to do loop 2, and I've kind of lost the picture. Let's do loop 2 in reverse. We would end up with I2 R2. All right, so we're going to do loop 2 in reverse. And I guess it doesn't matter where you start, but we're going to start right here, and then we're going to go around this way. Okay. So we would have I2 R2, and then we would have minus V2 minus I3 R3, and all that should equal 0. Okay. So we're going to have minus V2, and then this would be V3 is equal to I3 R3, and that'll be minus that as well. Okay. So that'll give us that other equation. All right. And so if you multiply all of these by -1, then you'll get the negation of this minus I2 R2 minus V2 I3 R3 equals 0. And this would be going forward. And so if you look at that carefully, V1 minus I1 R1 minus that's the results of equation 1 plus equation 2. And so if you add the forwards together, you'll get some canceling. The I3 R3 cancels out. And that's how you get this whether you do forward or reverse, that's how you get these two equations by adding loop 1 and loop 2. Okay? And that's what they were trying to show. And so basically what they're showing is that mathematically what gets canceled out when you sum loop 1 with loop 2, these middle terms get canceled out. So loop 3 is the sum of loop 1 and loop 2, but mathematically V2 and V3 get canceled out.